This is a video tutorial about Midas NFX. I will show you how to do a response spectrum analysis on a steel brace frame. So here you have your model inside the analysis mode of Midas NFX. First thing, I will just hide all labels, all guiders, because I cannot see very well my model. Now the first thing I have to do is to assign some constraints to this model. So I will create some boundary condition. I can give a name to it, and I just have to select the nodes where I want to apply my constraint. So 6 nodes, and then fix it. Now first thing I will do is to do a model analysis on this model. So I will create an analysis case. I do that in fact to obtain the eigenvalues. So go in the subcase control panel and enter 50 for the number of nodes. OK. Then just launch the analysis. Okay, so now you have all your results from all the model characteristics here, and if you double click on eigenvalues, you will be able to see all the eigenvalues of your models, all the modes, the eigenvalues which correspond to these modes, and a lot of others parameters. Now if you look in this table, we will be able to see in which mode and which translation we have the more deformation. So here you see for the T2 translation we have the more deformation for the first mode, and for the T1 translation, deformation is the biggest for the mode number 3. Now what I will do is I will modify this model in order to do my spectrum analysis. So I will right click on function and select the model damping function. I will call it 2% damping. Okay, and I will just use a constant function 0.02. Okay. Now I will create my response spectrum function. So for that I right click on function, and here you have response spectrum function. Click on add, and in this window you have first to click on the design spectrum. Now choose the type of design spectrum you want to use. So let's use the arrow code type 1, and for the soil factor 1.2, 0.15, 0.5 and 2. Okay. And for the max period I will enter 6 seconds. Then you click on OK, and you have your spectrum function which is automatically added. Now I just click on OK, and now let's create our response spectrum load. So I click on response spectrum in the dynamic, transient heat and CFD analysis menu. First select the direction in which you want to apply your global response spectrum load, select the spectrum function you just created, enter a name, click on add and click on OK. Now I created one load in the X direction. Do it again to create it in the Y direction. Okay. Now the next step will be to create an analysis case, general, and select response spectrum, RS. Okay. And now you will have to create a second subcase. So the first subcase will be called X spectrum, and the second subcase Y spectrum. Sorry. Now assign all the loads to the two subcase, and for the subcase drag and drop the Y load here to inactivate it, and here the X load. Now click on spectrum X subcase control, and here you can choose the modal combination type you want to use. Go into general and enter 50 for the number of modes. Okay. Do the same for the Y spectrum. General 50. Okay. Now click on analysis control and check the function modal damping function. And here you have to choose the function I created, 2% damping, and just click on OK. Now you can run your analysis. So click on perform. Okay. And you can view your response spectrum directly here. So you can view the animation on your frame. So this is the response for the Y direction. You can view the results for the forces, axial force, the bending moment inside your frame, the B axial force in the bars. And for the Y spectrum, so this is the total displacement, and the same, you can view the axial force